Alright, this is part 2 of the polar graphing. Again, all this information that I'm about to go over is on a sheet on Canvas, is what I've said to you before. So you can see it in case you've forgotten since the last time I'm talking about this thing. All the information, okay? It's not on this particular page because I didn't bother to take pictures of both sides. But it's there, so go look for it. So now we're going to talk about how to graph these different limaçons. Okay, and the limaçon that I'm referring to, that's my attempt at French. And I keep forgetting what this is supposed to be, this little symbol underneath. It's what makes it that son sound that I'm trying to do. So I hope you're having fun laughing at me. Anyway, so don't you dare call them a limacon. Now, there's certain limaçons that have their own name. And again, all of this is on that sheet. I would encourage you to look at that, have it handy as I go through the steps about what I'm about to do to graph this thing. So it's going to look like either this or this. And I'm just going to do examples as we go because all that information is there. So in this particular instance, because the absolute value of A is equal to the absolute value of B, in other words 2 equals 2, this is a cardioid. Alright, what in the heck do all these shapes look like? Well, I'm going to do my fluorescent orange here and I'm going to show you. A cardioid is going to have a shape that's, if this is the graph, it's going to do something like this. Oh, it's going to not be quite so heart-shaped. I'm back in elementary school. And then you're going to have a limaçon with a slight indentation. And what is it going to look like? Well, it's going to look kind of like this. And that indentation that we're talking about is right there. So this is one with a slight indentation. I'm not going to write the word limaçon. And then you're going to have one that is going to have an inner loop. So it's going to do something like this right here. So it's going to kind of look like a cardioid, but you've got the inner loop. So while I'm got these beautiful little orange pictures on the side here, let me get another fluorescent color so I can highlight some things. Okay, when you do this graph, you're going to need to find points on the wing and on the bulk. So you're going to need to find 2 points, and then you're going to use symmetry to find those 2 points. For the slight indentation, you're going to have to find a point on the wing and a point on the bulk, and then use symmetry for that. The bad news for the inner loop is you're going to have to find something on the wing, you're going to have to find something on the bulk, but then you're going to have to find something on the inner loop. I expect you to find 3 points to help us with the reasonable job of the shape of this thing. And again, when it comes time to do all this, you're going to ask me, what angle are you picking? Well, most of the time to make my life easy. When I get into the inner loop kind of question, there's a little bit more discussion that has to go into that. Now, when I do the inner loop discussion for all the Calc 3s out there, I don't think you're going to see very many of those when we do this stuff in Calc 3. Whether it be from Chapter 11, the stuff I didn't do in Calc 2 that I said we're going to do together in Calc 3, or when we do polar substitution for the double integrals. Alright, so let's go back to the problem that I was working on. And I don't need to use neon colors anymore. Okay, so there's some different things that I need to identify. First of all was the fact that I have a cardioid, so I guess we could do that first. And this order may be different than what I talked to you about before. And so one of the things you need to do is get the direction of the bulk. Alright, the bulk is that fatter part. And what you have to do is you have to look at this part right here. That -2 sine theta. Alright, that's telling me the bulk is going to be in the quadrants where sine is negative. So the bulk is down. because down is quadrants 3 and quadrants 4, and I'm going to erase that real fast. So that's why it's down. Alright, so we need to get that. Again, the order may be different, then I don't have that sheet memorized. The back end of the bulk is going to be what you'd get when you add those numbers together. Well, if you just take the absolute value of them, it's going to be that 4 that you see. It's going to be just add the numbers, don't care about the sign. We're done with the sign once we realized that the bulk was going down. Alright, the wing is going to be whatever A is. And A is equal to 2. Remember, A is the coefficient, or the constant part, I should say, not the coefficient. Alright, and then I need to find a point, actually 2 points, to finish the job for a cardioid. So let's see if I'm going to do it down here so I have more room. So when you look at that equation, let me give you 2 guesses, no, 1 guess, as to what angle I'm going to use. Alright, if you don't choose 30 and you don't choose 210, I don't know what you're thinking, because I want that to be the sine of a 30-degree reference angle. So if you still don't know what the heck I'm talking about this. So my brain does not have to work so hard. And I end up with a 2 minus 1, and the answer is a 1. So I have the point 1 comma 30 degrees. That's one of the points that I have. To do the same thing for the 210. I'm going to have r is equal to 2 minus 2 times a negative 1/2. You know it's a 1/2, I hope, and it's going to turn out to be 2 plus 1, where r is equal to 3. And that's the point that I'm going to graph for this one. Alright, I'm running out of room here, but I need to make this picture bigger so you can see the actual graph. I hope I remember all the different numbers when I do this. Let's do the locations in black. So the bulk is down, and I need to go 4 units down. The wings are always perpendicular to the bulk, so if the bulk goes down, the wings go right and left, so I went 2 units that way. Now I'm going to do the 2 points, and I want to do these in different colors. This point right here, here's the 30-degree angle. I'm supposed to go out to 1. And then the same thing happens with the other side. Here's the other 30-degree reference angle. I'm doing a 1 right there. So when I graph the wing is going to look like this in blue. That's the wing. Alright, let's graph the bulk. And so when I graph this point, 210 is located right here, and 330 is located here. And I'm supposed to go 3 units, which is going to be this location, and 3 units, which is going to be this location. And then I'm going to graph, to the best of my ability, the bulk. So the bulk is in purple, and the wing is in blue. I don't like the way that bulk looks, so I'm going to do it again and say, here's my bulk. And you just graphed a limaçon. And I need you to graph the points because symmetry is so important for these shapes and a lot of different shapes. We need to know that symmetry. You can't see my hands, and I know you can. I'm waving them around like a maniac right now, just so you know. Alright, so let's go on to the next one. And I'm going to erase all this other stuff that's on the right hand side. Alright, so a brief discussion about this equation. If A is bigger than B, and you have a 3, is that bigger than a 1? And the answer is yes. This is a limaçon with a slight indentation. Okay, I'm going to look at that and see cosine, and I see cosine is positive, so the bulk is going to go to the right, because that's where cosine is positive, is to the right. Again, all this information is on that set of notes that I typed up so many years ago for my students because I'm such a nice guy. Alright, so the back of the bulk, I'm just going to call it back because I'm tired of writing. It's going to be 3 plus 1, taking absolute values of course, and it's going to be another 4. Alright, the wing is going to be 3. Okay, and or A is equal to 3 if you like that better. And then there's something else you have to get here before I can do the points, and that's the slight indentation. And what you have to do is the absolute value of A minus the absolute value of B, which basically is 3 minus 1 or a 2. Now I need to move this up so I can find a point, actually 2 points still. And I think I'm going to do it off to the side, so let me get something bright and cheery. Let's do a nice orange for this thing. So I'm doing a cosine. So guess which angle I want to pick. Good, 60 degrees. Why? Because I know 60 degrees is 1/2. Why am I doing that? Because I don't want to get a calculator out if I don't have to. There is going to be a time I have to get a calculator out when we do the inner loop. Anyway, so when I put 60 degrees into that equation, if I remember the equation, it's 3 minus plus 1, the cosine of 60. So this is going to turn out to be 3 plus 1/2, or 3 1/2. So I know I have a point that is going to be 3 1/2, 60. Now, I don't want to pick 300, I want to pick 120 because I need it when it's going to be negative. So when I put that in, it's 3 plus 1, and the cosine of 120 is a negative 1/2. So this is 3 minus 1/2, and you get 2.5. So the other point is 2.5, and it's going to be 120. Alright, enough of that color. Let's go ahead and backtrack. Let's see what kind of memory I have. The bulk is supposed to go to the right, so I'm supposed to go 4 units to the right. So I'm going right there. The wing is 3, so I go up 3 and down 3 because it's perpendicular. And then the slight indentation is a 2, so I have to go 2 units opposite the direction of the bulk. And then I'm going to graph the points, and again I want to do it in colors here. If I do this point right here, I have to go 60 degrees, which is this angle, and I'm supposed to go 3 1/2 units. So let's see here, 1, 2, 3 1/2. That's this point right here. And on the other side, here's my 60 degree angle, and I'm supposed to go 3 1/2 again. So 1, 2, 3, 3 1/2 is right here. So when I draw the bulk, this time in blue, that's going to be the bulk, right there. Alright, let's do it in red. When I do the slight indentation, I'm supposed to do 120, go out to 2 1/2. 120 is this angle, 2 1/2 is located about right there. And if I do the same thing on this side, here's my 240, I'm supposed to go 2 1/2, 1, 2 1/2 is about right there. That may be a tad far. Alright, let me erase that because that looks a bit far. I want to put my own graphs on this next time when I start doing this video. So I hope I never have to do another video. Yeah, right. Alright, so when I graph this part, the slight indentation, it's almost like you take a rubber band and you push it ever so slightly. It's not as exaggerated as that other picture, but this right here in red is your wing. but it's like you have a circular kind of rubber band almost, and you push gently in this direction right here, and it gives it that slight indentation. Alright, so before I do the next example, I'm going to take a little break. Alright, break time's over. There's the last chance. There it all is if you want to see it all. And you need to write it down, so pause. I'll count to 3. See you later, bye. Alright, so this one is on a piece of paper all by itself. And so this is the one with the inner loop. And so let's see then. Let's go through the information. And I'm trying to figure out where's the best place for me to do it. And I'm thinking maybe I'll do it over here. So, because 2, the absolute value of 2, is smaller than the absolute value of b, this is a Lie-Mason with an inner loop. The bulk is up. Why? Because this is a positive 3 sine theta. The back of the bulk, I'm just going to say back, is 2 plus 3. And if they're negative numbers, you just take the absolute value of them and add them up. And this is going to be a 5 in this particular instance. Alright, the wing is going to be a 2, or A is equal to 2, however you want to think of it. And then the back of the inner loop, you have to take the 2 minus the 3 and take the absolute value of that, and it's going to be a 1. That's the back of the inner loop. So now I have to find 3 points, and that's the discussion we need to have now. So the first part is going to be obvious. I'm going to choose 30 for the same reasons I was choosing that stuff before. And I'm also going to choose 210. The third one, I don't know what I'm going to select yet. It depends on what in the world happens here for these two right here. So let's see what happens, and I'll tell you what we have to make our decision about. Let's figure out what the numbers are when we plug them in. Now, I don't anticipate any problems whatsoever with this 30 degrees, just so you know. It's 2 plus 3 times a half, and this is going to work out to be 2 plus 1.5. You're going to get 3.5. So your point is 3.5 comma 30. No worries there. This is the one that I have to see what happens. And you say, what do you mean by see what happens? Well, let me show you, and I'll tell you once we get there, your different options. When you plug in your 210, your R is going to be equal to 2 plus 3 times a negative 1/2. So you get 2 minus 1.5, and you get a 0.5. Now, because this is positive, you have found a point that is going to be on the wing. If this was a negative number, then you found a point that was on the inner loop, if this was a negative 0.5. But it's not. So again, I just want to make sure you hear me right. If you plug in this number and you get a positive, it's on the wing. If you get a negative, it's on the inner loop. Now, it's not an inner loop, so I'm going to erase that. But you need to notice that. It's not a big secret. It still goes back to all that stuff we did in trig, the first 4 quizzes. So, what I have to do to pick my angle this time, I'm going to need my calculator, but I have to think about the graphs and what's going on and all the stuff that we're discussing here. What I need to have happen is I need to have 2, when I do this angle up here, I'm just going to scribble some stuff down at the bottom. I need to have 2 minus a number that's bigger than 2. I don't care what the heck it is. That way I get a negative number. And if I get a negative number, I know it's on the inner loop. The only way that I can multiply 3 times some fraction, some decimal number, is going to be, it has to be big enough so when I multiply it, it gives me something bigger than a 2. So what in the world would that be? Well, I can tell you what it's going to be. It's going to have to be something that is going to be close to the negative 1 that happens only when you're at 270 degrees. So should I put 270 degrees in there, Soash? No, don't put 270 degrees in there. I might start with 240, and if that doesn't work, if 240 doesn't work, then I'm going to have to break down and do 255 and use my calculator. So, let's see what happens. I'm going to do the 240 and hope that I don't have all this extra calculation to do, but it may not be big enough for me to get done what I need to get done. So if I use 240, I'm going to scribble it all down here. My R is going to be equal to a 2 plus 3 times, and then 240 is a 60-degree reference angle, and that is going to be a negative square root of 3 over 2. Now, I happen to know that that's about a negative 0.86 something. Well, if you don't want to trust me, you can get your calculator out. I'll go ahead and do it on my calculator right now. I am going to do the 240, hit the cosine button. Oops, that's not what I got. I'm supposed to hit the sine button. Good job, Soash. So 240, hit the sine button, and I get a negative 0.8660. Oh my gosh, he's right. It happens every now and then. When I multiply it by 3, I end up with 2 minus 2.6, basically. Alright, that's good enough. I'm going to end up with a negative 0.6. So because I got that, when I did the 240, let me do this in a different color so you can see it. This point for 240 is going to be a negative 0.6 and 240. And the reason I know it's going to be on the inner loop is because that angle is a negative. Can't emphasize that enough. It's supposed to be erasing. Alright, so we're ready to graph this beautiful thing here. Alright, let's make this bigger. I hope I can remember all the numbers here. So the bulk is up. I'm supposed to go 5 units. So 1, 2, 3, 4, 5. It goes all the way up here. Get rid of those things. The wing was 3 if I remember correctly. No, the wing was 2. Good thing I checked. Which is here and here. The back of the inner loop was a 1. So I have to go 1 unit right here. And I'm getting stray marks. So now I just need to do points, but I need to do these in colors. So let's do the bulk in blue. So the bulk is going to be when I graph this 30 degrees and 3.5. So here's 30 degrees. I'm supposed to go 3.5. So here's 1, 2, 3.5. And I need to do the same thing on the other side, so I'm going to kind of just rotate, and I'd have this point right here. So I can graph my bulk. That is not my best bulk. Let me try that again. Alright, so I'm done with the blue, so we can go into a different color. Let's do the wing in green. So the wing comes from this information right here. So I need to graph the point. I never wrote it, did I? Well, I don't think I ever wrote it. So what I'm going to graph is the point 0.5 and 210. So 210 is located about right here. I need to go 0.5. It's very, very small. And I need to do the same thing at 330. I need to go 0.5. So my wing is going to be that small little region right there. And last but not least, we're going to do the inner loop that you can see if I'm able to do that. Is going to be that number. And I can erase that. So 240 degrees is this angle, and 300 is this angle. So I'm supposed to face this way, but go backwards 0.6. So it's going to be about right here. I need to do the same thing on the other side, and here's your inner loop. Some people say, or if you look up les maisons in French dictionary, it is snail-like. Alright, take a gander of all that, if I can get it all on the screen for you so you can see it. And again, I'm going to count to 3, and we got one more shape to worry about before we stop on this video. Alright, here we go. Alright, the last ones we're going to do, and yes, there's only 2 of them we're going to do. These are roses, okay? If you want my honest to God opinion, I really think they look like daisies instead of roses, but that's what they call them. Now, there's different things that you need to be aware of, okay? And it has to do with the number of petals. And plus, how do I know it's a rose? Alright, this thing right here looks like the r equals 2 cosine theta, and that's going to be a circle that's over here. But because this has a 2 theta, that's not a circle, it's going to be a rose. Or it has a 3 theta, it's going to be a rose. So any number other than 1 is not a circle, it is a rose. Alright, again, I don't remember the exact order, so I'm just going to go ahead and try to ad lib here. So this may not be the order that's on that set of notes. I suppose I could take a quick gander and I could, nope, I can't because I didn't print that side of it. Oh well, so sad. Alright, it's going to be four petals. How do I know it's 4 petals? Because if the coefficient here is even, then the number of petals is going to be that number doubled. So we're going to end up with 4 petals. Now, you know what that really means? It means there are 4 axes of symmetry. Isn't it easier to write petals than axes of symmetry? So that's what we're going to do, is call them petals, even though they're axes of symmetry. And it has to do with the fact that this right here has an even number. If that was an odd number, I guess we might as well do these simultaneously so you can see it. The number of petals here is going to be whatever the heck the number is. It's going to be 3. Oops. I don't want to do that. I just want to erase that. Alright, so let's see. The first petal, or first axis of symmetry, it has to do with, and I don't think I have the energy to do the trig solving equations again. It's going to be whatever would make this the biggest number, and that is going to be when theta is equal to 0 degrees. And again, I don't have the energy to do it, but I'll try to do it here. This has to be equal to 90 degrees because the sine of 90 gives you the biggest number. So if you do substitution and do all the wonderful stuff, then theta, the first petal, has to be at 30 degrees. Alright, so if you're looking for a rule, I can give you a rule. Oh heck yeah, I can give you a rule. And again, all this is on that sheet. If you don't print it out or look at it, you're crazy. For cosine, it's always going to be a first petal at 0 degrees, always. Because that's where the biggest value occurs. If it's going to be tangent, sine, you got to do 90 divided by whatever this number is. I'm talking about that number. So if that number was a 2, I'd have to divide 90 by a 2. If that number is a 5, I'd have to do 90 divided by a 5 if we had r is equal to 4 sine 5 theta. Sorry about that. Let's try writing it again. I would have to do that for the first petal. So this is your rule, and again, it's on that sheet. Alright, so again, we're doing this simultaneously. The maximum length is going to be whatever the heck the coefficient is, whatever A is. In this case, it's a 2, and the maximum length is going to be a 4 in this particular case. All right, something else we need for both of them is the distance between petals. Okay, so basically I'm talking about an angle. So the distance between axes of symmetry, all right, I am going to use it. I'm going to write it over here. This is going to be 360 divided by the number of petals. So again, I'll erase this. Well, heck, let's just erase this. So the thing you should remember for the distance between petals is 360 divided by the number of petals. Not n, the number of petals. And so for this example right here on the left, that means we're going to end up with 360 divided by 4 is going to be 90 degrees between petals. For this one over here, okay, this is going to be 360 divided by 3, and it's going to be 120 degrees between petals. So this one is 360 divided by 4, or 90 degrees. This one, the distance between petals is going to be 360 divided by 3, or 120. All right, last but not least, we've got to find one point and then use symmetry. Yeah, you do. All right, so I'm going to erase all of the stuff on the right-hand side because I think I need more space to do this part. And black shows up on that opaque color that you have. So when I find a point, then I have to look at that equation and figure out what I want to put in there. So for this one, I want to choose 30 degrees. How come you're doing that? Well, just watch. Come on. R is equal to 2 cosine, I didn't leave enough room. R is equal to 2 cosine 2 times 30. R is equal to 2 times the cosine of 60. Oh my gosh, look at that. Isn't that nice? So this is going to be a 1. So the point we're going to have is 1 comma 30. And that's all I need to get the rest of the shape for the graph. For the number, for this point, or for this one, I'm looking at that and I'm thinking, do I really want to put 10 degrees in there? No, I don't. Why? Because I don't have 10 degrees marked. Every one of these highlighted things is 15 degree multiples. So it's 15, 30, 45, 60, 75. All right, so I don't want to do that. So I'm going to break down and use 15 degrees. It's not ideal, it's not perfect, but it's okay. So when I put that into my equation, when I put that into my equation, I'm going to have 4 times the sine of 3 times 15. How come you use 15? Because the sine of 45 is something that I know approximately good enough for my purposes. And I'm erasing this from the previous calculation, so I have some room to work. So I'm going to have R is equal to 4 times that square root of 2 over 2, which we've already talked about how it's about 0.7, and we get 2.8. So the point that I'm going to be using is 2.8, 15 degrees. Alright, so here we go. We're going to graph both of these. I'm going to try to leave enough stuff on here so I can see. So since we're talking about roses, I'm going to make my petals green. No, not really, but I'm going to pretend like they're leaves. So I have 4 petals. Maximum length is 2. Alright, this is going to be very squashed, but oh well. Here's going to be my... Oh, don't go away! Crap. I magically deleted that thing. So my only hope here is to go over here to that graph paper thing that I showed you, and I'm going to do them here. Oh, not that way. Alright, so I hope I can remember. I'll be doing a lot of bouncing back and forth. So I'm supposed to go 2 units in this one, and I'm supposed to do that every 90 degrees. That's where I'm going to have the maximum length. This actually shows up a little bit better maybe. Maybe it's a good mistake or accident. The other thing that we had, and I forgot what it is the point. And the point was, hope I didn't erase that, 1, 30. So here's 30 degrees. I'm supposed to go 1 unit. And I really should do a different color so you can see it better. And so by symmetry, I need to do the same thing. So this is 30 degrees away, or 2 spokes of the wheel. So I need to go 30 degrees on the other side. So one of my petals is going to look like this. And I need to do the same thing for every one of these. I need to go 2 away from each axis of symmetry. 2 petals from each axis of symmetry. So I'm going to have this petal, and I forgot to do this one, this point. I'm going to have this petal, and then finally I'm going to have this petal. So there's the graph of, oh, what in the heck was that? Oh, I know how I should be able to do this, because I'm going to make you write the equations from the graph, and I know that that's going to be r equals 2 cosine 2 theta. Good job. So the next thing I've got is let me go back and look at it one time. I've got 3 petals. I've got the first petal at 30 degrees. I've got 120 degrees between them. Maximum length is 4. So let's go back to the graph. And the first petal is at 30 degrees is what I think I remember seeing. So that means I'm supposed to go 4 units. Then I'm supposed to go 120 from 30. That adds up to 150, and I'm supposed to do 4 units. And then another 120 plus 150. Don't you dare cut that. And I'm going to have that point right there. So I've got the points. And now I need this point, which was 2.8 and 15 degrees. I want this to be purple this time. So I'm supposed to go 15 degrees and go out to 2.8, which is about right here. Now this is 1 spoke of the wheel away from the axis of symmetry. So I have to go 1 spoke of the wheel away here. So one of my petals is going to look something like this. And I'm supposed to do the same thing over here. I'm going to go 1 spoke of the wheel, 2.8, 1 spoke of the wheel, 2.8. I'm going to do 1 spoke of the wheel, 1 spoke of the wheel. So my other petal is going to look something like this, and my last petal is going to look like this. Yay. So that to me looks more like a whirligig than a rose, but again, just to refresh your memory, the equation was 4 sine 3 theta, not because I remember it, because I see the graph. And I really wish I could stop here, but there is something else that I need to make sure that we practice. I'm so tempted to stop. And that is, how do I take the equation, how do I take the graph and write the equation for this thing? Well, this ought to be fresh in your mind. We just talked about this thing. All right, this is going to be r equals, and the maximum length, according to what I count, is 1, 2, 3, 4, 5, 6, 7. So I'm going to have 7 for the maximum length. And since this first axis of symmetry is at 0, I know it has to be the cosine. And how many, or what's the n here? Well, if it's an odd number, it's going to be whatever number of petals you have. If it's an even number, then you're going to have to divide the even number of petals by 2 to get what the heck n is. So there's an example of going from the picture back to the equation. All right. Then I've got some of these. I'm not going to do them all. I don't have the energy to do them all, but we can talk about a couple of these, and I think I should use a different color to highlight things. All right, if we looked at number 2, this is just a circle that is going to be tangent to the pole. So I know it has to be r equals some number. The number is going to be a 3, but what kind of 3? Because it went to the left, it has to be a negative 3, and it's going to have to be cosine because that's where cosine is negative in quadrants 2 and quadrants 3. There's your equation. If you were to do this one, well, 1, 2, 3 again, so that's not very thrilling, but it's sine because, and it's positive 3 because it's in quadrants 1 and 2. All right, there's other circles, you can play with those. This one is a cardioid. That's the correct spelling. I noticed my wife typed something wrong in one of those problems, or set of notes. It might be a different set of notes, though. I've been looking at too much stuff. So I know, because of the format of this, it's going to be a plus b, and it's going to be sine of theta because the bulk goes up. The wing I can get very easily because I just have to count this distance right here. And this distance, according to what I see, is a 3. But I have to figure out what b is. So there's only one way that I know of that we can figure out b. I have to take this whole distance, which is a plus b. And I count 1, 2, 3, 4, 5, 6. Well, it's got to be a 6, and if I do 6 minus 3, that has to be a 3. Oh, but wait a second, Sus, you're too tired. Why aren't you waking up? If it's a cardioid, these have to be the same numbers anyway, so I didn't have to figure it out doing that subtraction. But if it's a slight indentation or a inner loop, then I might have to do a calculation like this to figure it out. So there's the answer to number 5. Let me move that. Let me try to move that. And let's do number 9 since I haven't scribbled all over that. And this is what I think I'm going to stop at this one right here. This is a limesson with a slight indentation. I wish it wasn't up, but it's too late. I picked it. So it's going to be this. And I know that my b has to be a positive number. So my a is going to be 1, 2, 3, 4. And, well, honestly, there's 2 different ways to do it. You know that this distance is a plus b. So if you do 4, that leaves you with 3 left over. So you have to go 3, so that's 3 sine of theta. The other way to figure it out is this measure is 4, it's a minus b, or 4 minus 3 to give you a 1. So here's your equation. So again, this is just a quick taste of some examples that you can get lots of practice on with this old test. And again, this old test that I called a review from Math Analysis, I think the date on it's 1985, just by the way. Anyway, that's on Canvas. It's got the answers. You got all the things you need to do to practice, and it's got everything on both of these that we've done. So I need to stop because it's going way too long.